Alright guys, in this video we will learn how to solve and graph quadratic inequalities. Take note of the fact that we only have x values here, no y values. When we only have x values, that's a hint to you that we will be doing a number line graph, and we'll be doing interval notation. So there won't be any shading, it'll be a number line that we're shooting for. Alright, let's go ahead and put this equation in our calculator and see what we've got. Let's see, x squared minus 2x minus 8. And we'll just hit enter a few times. Alright, so we have 1 comma negative 9. Alright, so at 1 we're down at negative 9. At 2 we're at negative 8. 3 is negative 5. At 4 we're at 0, and then 7. And at 0 we're back at negative 8. So I think we can see where the vertex was, so the mirror images will start to kick in right about now. Okay, but you could check on the calculator. Negative 3, 7, I bet. And sure enough. Alright, so we've got our parabola graphed. Let's go ahead and just connect the dot. Whoops, let's go ahead and connect the dot. Now, as we look at this equation, it says, where's the function less than 0? Okay, that means below 0, which graphically means where is it below the x-axis. So let's just go ahead and highlight the part of this graph that is below the x-axis, and that's going to be right here. Okay. This is the part of the graph that is below the x-axis. Alright, but if we wanted to turn that into a number line graph, because again there are only x values, no y values, so we need to turn this into a number line graph because all we want are x values. Now this says where's the function less than 0, not equal to 0. So these border points right here are where the graph is equal to 0. So I'm going to leave these as open circles, and I can see that the solutions, the x values, are here between negative 2 and 4. So I can just, if I just want to show only the x values, then I'll draw this line. I should draw it a little bit thicker. I'll draw this segment between negative 2 and 4 to show all the solutions between negative 2 and 4. Okay, but the main thing we need is the interval notation. So the interval notation for this will be negative 2 to 4, because that's where the x values go, from negative 2 to 4. And we will leave these as round parentheses for the same reason I put these as open circles. We're not including the parts that are equal to 0, so we have to leave out the negative 2 and the 4. Alright, so that's problem number 1. Alright, number 2, let's go ahead and graph this function. Alright, I think that's right. Negative x squared plus 4x plus 5. Yep, let's take a look. Alright, so the first point that seems to fit here is negative 2, negative 7. Okay, so at negative 2, we are at negative 7. And then, let's see. And then we have 0, 5, and 8. So we'll be at 0, 5, and 8. Okay, and then we're at 9 and 8. And then you can see the mirror images are happening after that. So I'm sure at 4 we'll be at 5. And at 5 we'll be back to 0. And of course at 6 we're back to negative 7. Okay, let's draw it. And again, as we look at this equation, we're looking at the symbol greater than or equal to 0. So where is the function greater than or equal to 0? Well, let's start with where it's equal to 0. And I can tell you that it's equal to 0 right here at the x-axis. So now where is it greater than 0? It's greater than 0 above the x-axis. Okay, so these are the solutions, but we only have x values here. There's no y here. So I need to translate this into x values only for a number line graph. So the x values are again between the two x-intercepts. Okay, so I will flatten this out into a number line graph. And so just looking at the blue only, just the x values, that's what we use to create the interval notation. So the x values here, these solutions, go from negative 1 to 5. And this time we want it equal to 0 as well. So we'll include the endpoints by using square brackets. Okay, so we'll say, oh, it's from negative 1 to 5 with square brackets. So that would be your answer to number 2. Alright, looking at number 3, let us add 2 to both sides before we get really started here. And that's going to give us negative x plus 2 squared minus 1 is less than or equal to 0. Okay? And then this is the inequality that we will be dealing with from this point forward. Alright, let's go type it in the calculator and see what we've got. Okay, so we have negative x plus 2 squared minus 1. Right? Yep. Okay, those numbers are very large. Alright, there's one that fits. 1 comma negative 10. So let's graph that. Okay, 1 comma negative 10. That's way down here. Okay, and then we've got negative 5, negative 2, and negative 1. So at negative 3, we're at negative 2 again. Okay, so you can see the mirror image happening. That's why we have negative 5 and negative 10 coming next. Okay, so there's our parabola. Let's go ahead and graph it. Alright, interesting. This entire graph is below the x-axis. Let's see how this turns out. Well, looking at this symbol, this inequality is asking the question, where is the function less than or equal to 0? Well, it's not equal to 0 anywhere, but less than 0 would be below the x-axis. And what part of this graph is below the x-axis? Yeah, the entire thing. Alright, this part of the graph is below the x-axis. The whole thing. So if I was going to translate this into a number line graph, I'd have to do this. Okay, I'd have to indicate the entire number line because that's the domain of this parabola. It goes from negative infinity to positive infinity. And the entire thing is a one big solution set. Okay, because the entire thing is less than or equal to 0. So if I want to capture this in interval notation, alright, the entire number line, that's simply negative infinity to positive infinity. So there's your answer to number 3. Okay, once again for number 4, let's get 0 on one side, so I'd like to add 1 to both sides like this. And that is going to give me x squared minus 4x plus 4 is less than or equal to 0. Okay, let's take a look at the graph. Okay. Alright, these numbers are huge. I'm just going to scroll down until I find a number I can graph. Alright, there's my first one. Negative 1, 9, my first customer. Okay, and then I'm going to have 4, 1, and 0. So there's 4, 1, and 0. And then I have 1, 4, and 9. Okay, so as you can see, at this point I'm just graphing every point off my calculator that fits on the graph. So I find that's a good place to start. Let's go ahead and draw the parabola. Okay, well, this is going to be another interesting graph. Look at the symbol, less than or equal to 0. This inequality is asking where's the function less than or equal to 0. Well, I can tell you where the function is equal to 0. It's equal to 0 right here. This is the only place where it touches the x-axis. Now, where is it less than 0? Never. There's no part of this graph that goes below the x-axis. So, so far I've just got the one single point that represents a solution. So if I wanted to turn this into a number line graph, I really couldn't make any arrows or anything because it's just, again, the single point. And even when I try to do my interval notation, it's going to wind up being the smallest interval. You know, I guess we'll just say that it goes from 2 to 2. Alright, it starts at 2 and it ends at 2. That's it. Okay, how about number 5? First thing we need to do is subtract 3 from both sides so we can see what we really have. So that's going to give me negative x squared plus 2x minus 4 is greater than 0. Okay. Alright, there we go. I like to start from the top. Okay, so I see the first value that fits is negative 1, comma, negative 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. Okay, so -1, oh yeah, -1, -7 is right here, and then we have -4, -3, -4. So -4, -3, -4. I think I see what's happening here. So now I have 3, -7. And I think these are the only 5 points that actually fit. Yeah, because then it's at -12, which I could probably stretch it. You know, it's like here somewhere. Anyway, you get the idea. Let's draw this graph. Okay, so quite another interesting graph here. I'm noticing that the entire graph is below the x-axis. Let's see what we're looking for here. Well, looking at this symbol, greater than 0, this inequality is asking where is the function greater than 0. In other words, where is the function above the x-axis? Which part of this function is above the x-axis? Well, no part of it at all. So that's why for this one we're just simply going to say no solution. Okay, that's all I really have to say about that. Alright, how about number 6? Got to subtract that 3 from both sides. Okay, so that's going to give us x squared plus 4x. These cancel out, so I'm just going to go ahead and say greater than or equal to 0. Let's see what this looks like on the table of values. Okay, what did I have? X squared plus 4x, and that's it. Okay, so x squared plus 4x. Alright, these values are still too big. We go up to this end of it. Okay, so my first value that fits is -5, 5. Okay, -5, 5. Let's go ahead and graph that. There's -5, and here's 5. Okay, and after that I have 0, -3, -4. So 0, -3, -4. And then after that I have -3, 0, 5. Okay, and you can bet because of the mirror images, the next point is also off the graph. So let's go ahead and graph. Alright, so here's our graph, and let's look back at the inequality. Now, concentrate on this symbol right here, greater than or equal to 0. So it's asking where's the function greater than or equal to 0. In other words, where is this parabola either above the x-axis or on the x-axis. So it's equal to 0 right here, okay, on the x-axis. And it's greater than 0 up here, okay, where the parabola is above the x-axis. And there's another piece of it over here, okay, again where it's above the x-axis. Alright, so I have these two branches. Now again, there are no y values here, so all I really want are the x values. So I'm going to show that by making this into a number line graph. So these green parts are the solutions right now, but I'm going to flatten them out into a number line. So I'm going to start here because this branch goes from here and then it goes to the right if I'm doing a number line, and it goes to the right forever. I'll go ahead and let it go to the edge of the graph. Similarly, this branch of solutions starts at -4 and goes to the left. So when I write my answer in interval notation, it's going to take two separate parts to the interval. Okay, the left part goes from negative infinity to negative 4. And we'll use a square bracket to show that we're including the equals 0 part at negative 4. And then the other part starts at 0 and goes to infinity. And then we'll always use a union symbol when your solution set occurs in two different parts. That shows that this is all part of one solution set. And that's it. That's the answer for number 6. Okay, and I think that is the last problem in the lesson. I hope it was helpful for you, and I will see you on the next video.